Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. CrO3 in pyridine, also known as Collins reagent or the Surrett-Collins conditions, is a mild oxidizing agent selective for primary alcohols, oxidizing them to aldehydes without over-oxidizing to carboxylic acids. Secondary alcohols are oxidized to ketones. However, the key feature of CrO3 pyridine under cold conditions is that it is a mild oxidant that preferentially oxidizes the more reactive primary alcohol to an aldehyde and stops there. Moving on to the next step. Identify the substrate. The starting material is CH3CH or CH2CH2O, which is 1,3-butanediol, 4-hydroxy, 2-butanol, 1-hydroxy, 3-butanol. It contains two hydroxyl groups, a secondary O on C2, CH3CH, O dash, and a primary O on C4, CH2O. Moving on to the next step. Determine selectivity of CrO3 pyridine, cold. CrO3 in pyridine is a mild oxidant. Under cold conditions, primary alcohols are oxidized to aldehydes, not further to carboxylic acids. Secondary alcohols are oxidized to ketones. Both of groups can be oxidized. And for the final step, apply oxidation to both groups. The primary alcohol, CH2O, is oxidized to an aldehyde, ChO. The secondary alcohol, CH3CH, O dash, is oxidized to a ketone, CH3C is equal to O dash. This gives the product CH3C is equal to O, CH2C is equal to OH, which is 4-oxopentanol or more precisely 3-oxobutanol methylglyoxal type. Specifically, the product is CH3C is equal to O, CH2 ChO. Match two options. Option B is CH3C is equal to O, CH2C is equal to OH, which corresponds to oxidation of both the secondary OH to a ketone and the primary OH to an aldehyde. This matches the expected product under CrO3 pyridine conditions where both alcohols are oxidized. Why other options fail? Option A. Only the primary alcohol is oxidized to aldehyde, secondary OH remains unchanged. CrO3 pyridine oxidize both alcohols. Option C. The primary alcohol is overoxidized to a carboxylic acid. CrO3 pyridine under cold conditions does not overoxidize aldehydes to carboxylic acids. Option D. Only the primary alcohol is oxidized to a carboxylic acid, overoxidation and secondary OH is unchanged. This does not match CrO3 pyridine selectivity. Therefore, the correct answer is B. Therefore, the correct answer is option B.